Get going.
Is that 3 negative 2 is the parentheses supposed to be?
Yeah.
That was weird.
Thanks.
Who's still on? Really? Oh, I got one. All right. Who's taking AP test tomorrow? Wow, she stands alone. All right. You need that. So, the early release really monkeyed with us. Like both of these units, Chapter 7 and Chapter 6, are like 5 days exactly. And getting a half a day, it's just like right there. So we didn't get everything we needed last hour. I'm assuming we'll end up in the same place today. That means what we're going to have to do is tomorrow we're going to finish the last like 2 examples of hyperbolae, and move straight into 6-1, which I'm okay splitting 6-1 over the Chapter 7 quiz, because the beginning of 6-1 is review of 3 variable systems. We're just going to start to force a certain organization to it, leading into matrices. So tomorrow will be finish 7-3, start 6-1. Your quiz will be moved to Monday instead. And then we'll continue 6-1 on Wednesday, and on and on and on and on, and everything else should be fine. Okay? Just we're that close. Like an extra half hour and we'd be fine. So, if my vertices have y's changing, that tells me that I have a tall potato. I have vertices north and south, which means it's going to be stretched vertically. Additionally, that distance is going to be 2a, my major axis. It's 10 units long. A is 5. So I'll go label vertex 1, 3, 6. Vertex 2 is at 3, -4. And halfway in between them is my center. This thing's a little sideways. So, find your midpoint. Going to have a center of 3, what? Uno. Yep. Already that gives me enough information for x minus thing squared plus y minus thing squared is 1 over. That already gives me enough information to put in what, and what.
H and K.
I got h and k. What else? I got a is 5, so a squared is 25, and I know it goes with which one? The y's. The distance between foci, so those are going to be labeled already. And I'll also make those purple so I know that that was already there. It's going to be 3, 4. Focus at 3, 4. Focus at 3, negative 2. That distance is 2c, so c is 3. But that doesn't help me with my equation, unless I take a side quest. What do we do with it? C is the square root of a squared minus b squared. In this case, 3 is the square root of 25 minus b squared. Square it, you get 9. Subtract 25, you get negative 16. Divide by a negative 1, you get b squared is 16. But did you also put your co-vertices on there? 4 to the right, 4 to the left. At 7, 1, and at negative 1, 1. No, you don't get to just add it in now and claim that you got a 5 out of 5. Did you have the coordinates at all?
Yeah. You want to check?
Well, you already wrote it. That doesn't prove anything.
This and then the C and B. And it's fine if we, like, just...
Chicho, Guido, smack him.
It's fine if we just label the dots without the coordinates as well?
Yes, remember if you have all of your coordinates labeled off to the side and you just have proportionally labeled a bunch of V, F, C, and CVs on your potato, but it's labeled correctly off to the side, also cool. Okay, so there you go. We gotta do this one a little weird because of all the interchangeable parts and one thing domino effects into the next. So what I'm gonna say is, did you get your center and have it put correctly in your equation? Did you get your A value correct? Did you get your B value correct? Did you put them in the correct orientation? So you actually have this stretched vertically and then put those coordinates in the correct spots. And then the last one would be, what did I say? Oh, you actually wrote your co-vertex. Because remember, purple was already there. That was all given. So you found your A, your B, and your center correctly. You have them in the correct spots. You actually labeled your center and your co-vertex. Okay.
Oh, I should not CV. I had the 7 and negative.
Oh, yeah, every year there's kids who will do that. Y'all, you can't just have that on your paper. That's not an ellipse, that's a scatter plot. At least draw the potato. Okay? All right. I only had one person ask about a thing, and it was just, why am I goofing up my complete the square? And it was because they weren't, did I really add 1? No, it was 9 times 1. That was the only thing that I had a question on. So more a question of procedure, algebraic correctness. You got anything for me? Cool. So with that, 2 items. One is just my own curiosity. I'm asking all my classes about this. What's your temperature on Greenwald?
Never had a teacher.
I've heard love them, hate them. Nowhere in the middle. I don't know because I know people love my class. I know people hate my class. I know, like, I only know what's in my room because I never leave my cave. I'm just wondering, because he's going to be taking Skoglin's place next year.
He's not.
I know.
Yeah.
I know.
He's over half.
Okay. So, okay, so that's just kind of the vibe that I got is people are like, hee or, and it's the same with every teacher. I was just wondering if there was an overwhelming, resounding one way or the other, and there isn't, and that's just normal teacher. Okay, cool.
Literally. Like.
Oh, it does kind of the Bueller thing?
All the time.
Bueller. Bueller.
He's like.
All right, I'm just wondering. Okay. Because I don't get out of my cave. I don't know what other people's classrooms are like. The other part. What was the other thing? There was a thing. Remember, I put it up there. I'm gone during Spartan time today. If anyone is planning on coming down, we're going to be switching our quiz over to Monday. Anyone with the AP test has notes. There was another thing. Lost it. So in the middle of what we're doing today, I'm just going to go, oh, and we're going to talk about it. In the meantime, I'm going to back that math up. We left talking about eyeballs. Okay. Oh, there it is. Okay. So we've been doing a lot of complete the square in here, right? And that's one of those things that you have forgotten how to do 3 times now. Let's be honest. Would you say that you need to know Algebra 2 to be in this room?
Yes.
Okay. I heard a very disturbing thing from Mrs. Work yesterday. Turns out that when she was gone for semester during out on child leave, that it sounds like her Algebra 2 basically cheated their way through not just the homework, but also the tests for all of chapters 4 and 5, quadratics and polynomials. Was that second? Oh, second semester. So if you know what PreCalc is like, you are now the veterans. If you would please go talk to your compatriots and tell them, if you don't know how to quadratic and polynomial, don't take PreCalc. Go take Algebra 2 again, because you cheating your way through that literally means you are screwed next year. So if y'all could be my ambassadors and go tell them they actually need to know how to do that stuff, that would be awesome. Okay? I don't know. She just said that. She sounded pretty upset, which means you're going to have a good chunk of kids coming up to pre-calc who literally don't know how to Algebra 2.
It is true because I've heard from kids in that class.
Yeah,
and they're gonna get whomped. Y'all are doing great. Like collectively, we got 48 kids. The majority are A's and B's, handful of C's, 1 D, and it's almost a C anyway. Like y'all are doing good. You know what you're doing because you did well in Algebra 2, even if it was a long time ago. Like we picked up the ball and ran with it. You've done good in here because you have those fundamentals. Just tell your peers that if they don't have those fundamentals, this is gonna hurt. Okay, you have to know. We say a minimum of a C in Algebra 2, not, well, you should have a C and you're fine. Minimum, because if you don't and you come in here, you just won't pass. A minimum of a C in Algebra 2 coming into pre-calc means you're gonna struggle. That's the minimum. So just talk to your peers and tell them, hey, make better life choices. Because otherwise, next year is going to be a real rough go for them. And I like it when kids do good. Happy dance. Okay? When kids do bad, it makes me despise things like white 4 freshmen. So we're not going to do 4 at the bottom there because it's literally the exact same thing. It just switches to 25, oh, that's the same. Switches from 0.28 to 0.39. You could just calculate or shortcut it with 0.39 instead. So I'm not going to bother with that. Were you all good on the whole eccentricity thing? Yes. C over A. Make sure you can simplify radicals. Okay. What we kind of glossed over with that yesterday was, remember that as the eccentricity, as that focus gets closer and closer and closer to the vertices, as it gets pulled further and further out, the eccentricity gets really close to 1. And at 1, what happens? It's just a line. What would happen if I took those foci and I pushed them past the vertices? Okay, I took these two parabolas and I kept stretching them, stretching them, stretching them, stretching them, stretching them, line, line, line. They go outside instead. Kind of like if we knew how to do our sine and cosine graphs, we could turn them into cosecant and secant graphs, right? Same thing's going to happen with 7.3. That's hyperbolae. If I go the other way, if I bring that closer and closer and closer and closer and closer and closer together, my eccentricity is 0. It's a circle. If it's a circle, that means it has a radius instead of A's and B's. If it has a radius instead of A's and B's, when I try to make my equation, and then I've got number over here, what happens when I divide by that number? Right? This would be the same as this, and I'd have 1. So what's A and what's B? They're the same thing. So if they're going to be the same thing, what I do is I just multiply by that denominator, or don't divide by it in the first place, and I leave it over here. Think about this again. Center is here. A and B are now the same thing. So I'm going to A and B this way, A and B that way, A and B this way, A and B that way. What is that? No, the A and B thing. The radius. It's a circle. Yes. And that's why it's called a center. That's why circles have their own special equation. And I just want you to draw your attention to that, is that if I see the coefficients are the same, I know when I divide, or the coefficients of x squared and y squared, when I see those two are the same, I know that when I divide, my denominators will be the same. So I'm just not going to divide, and instead of just having random number here, now I know that that number is radius squared. You are supposed to derive this in geometry because it's effectively Pythagorean. I have a center at HK. And my point out here is at XY. I know it's potato. My radius is here. Isn't how I find this via Pythagorean theorem and distance formula? Do you see it? X minus H is my horizontal distance. Y minus K is my vertical distance. Squared, squared, square root of that gets me hypotenuse. So they just left it as r squared. Like, this is just Pythagorean theorem and distance formula. That's why this is supposed to be a geometry standard. So I don't think this class specifically talked about that yesterday, but that's where circles come from. See, when one prolate really likes another prolate, that's where circles come from. So we're going to use that to define, I just get equation. What kind is it? Well, look at those three. I'm not even going to say anything yet. Eyeball them. Do you know? Argue with your neighbor. Do you know which one, without doing any math, is going to be a circle, an ellipse, or a hyperbola or a parabola? Why do you know it? Remember, even if you and your buddy look at each other and that one's a parabola. Yup. Why? Why is it a parabola? Can you articulate the reason?
Yeah. And it's
That was a real articulate description there, Kate. Because
and like B is a backward G, so I bet that one's a parabola. Yeah. No, the first one.
that's some freshman trying to do a multiple choice test kind of crap right there, dude. All right. What do we think? Why is a parabola?
Because there's one Y and one X. The Y is the square.
Only one term is squared. So I'm going to say that it's parabola. And I'm going to treat it as such. Go put it in its standard form. Group your X stuff together. Put your not X stuff to the other side. Complete the square. Half of -6 is -3. -3 squared is 9. Add 9 to both sides. That's also what I keep seeing incorrect the most on people's papers is they'll go from this straight to X -3, the quantity squared. But they won't actually write the +9 over there. Make sure you're doing it to both sides. Is 2y plus 4. Is it a parabola yet? Well, it is a parabola. Is it in standard form yet? What do we got to do? Lies. That's in vertex form from back in algebra 1 and 2. Standard form needs the 4p value. I need to factor 2 out to leave x minus 3 squared is 2y plus 2. Remember that each of these has their own standard form. Now you're right, I could get y by itself, and that is vertex form of a parabola. And it will help me graph the parabola. But it's not the standard form. Okay? I want you to be careful with those too. We're so used to these turning out nice. Think about when you were first doing algebra 1, algebra half. The good old days. I subtract this, divide by this, I got x equals 2. Life is good. And then you started getting things like x is 3 halves. X is -5/7. X is 51/78. And you said, I must have done it wrong. And then the teacher laughs like a cartoon villain and says, no, you didn't. Math is just like that. You're so used to these coming out nice. What if that was 3 halves y plus 41? What did it start as?
84.
You distribute into it, right? So can you work backwards? What if I had -5/4 y plus 37? Can you factor and find the 4p value and the k value? We're so used to these coming out nice. 148. Dude. Distribute. We tried showing you this in Algebra 1. Everyone blew us off and used their calculator instead. Okay, I would have to write that as a negative 5/4 in the p-value divided by itself is 1. When I divide by a fraction, I multiply by reciprocal. That's going to be at a negative 148/5. So just, I know that's not what was here, but here came out nice because they made it nice. It might not be nice. Okay? You know what, if I took that further,
Not even gonna try.
right? Just minus 7/2/15. It's just multiplied by a fraction, y'all. Okay? So just, all right. Now what? And then you have to rationalize it. Okay? So do you know how? This is my plan. This is what I'll do. That's what I care about. All right. They always come out nice for us. Well, not always. Most of the time they come out nice for us. Round 2, B, what is that? How do I know the difference?
Circles A and B value are the same.
You're looking specifically at the coefficients in front of the squared terms. Okay? If they're the same, then when I divide, they'll reduce to the same thing, so that means A and B are the same. So I just won't divide. So it is a circle. I will group my X stuff. I will group my Y stuff. I will put my not X and not Y stuff to the other side. I will complete squares. Who goes with X?
36.
Okay. Make sure you put it on the other side. Who goes with Y? And then we're already at answer. X minus 6, the quantity squared, plus Y plus 5, the quantity squared. $49. Because if I were to divide by that 49, I'm just going to have both of them over 49, which means A and B are the same thing. So don't do that. Just leave it like this. If I was trying to graph it, I'd have my center at 6, -5. And if my radius is 7, it's going to be really hard to write this coordinate because that coordinate will need to be written in terms of the angle that it's at, so it's going to be written as trig ratios. So it'll be like -5 sine of thing, 6 cosine of thing. And that's gross. So how about I just go 7 to my quadrantal directions? If the radius squared is 49, then the radius is 7. If the radius is 7, then I'll go 7 to the right. 13, -5. Come on, Frank. I'll go 7 to the left. I'll be at -1, -5. I'll go 7 north, 6, 2. I'll go 7 south, 6, -12. I'll connect them and hope it's circular.
It was pretty good until the very last, like.
I panicked when I saw the coordinate. Okay. And then this guy, what's it going to be?
Potato.
That was a potato.
That one's an actual.
Okay, how about a ellipse? Yeah. So I'm going to put my X stuff here. I'm going to put my Y stuff here. I'm going to put my not X or Y stuff over here. I'll complete the squares. Half of -6 is -3. -3 squared is 9, just like last time. What do I put with the Y squared then?
Zero.
Because remember, the quantity Y minus 0 squared is just Y squared. So I don't have to complete the square. There's just a 0 with it. Okay. So I have, we said it was a ellipse. I'm going to have X minus 3, the quantity squared. I'm going to have Y squared equals 1. When I divide both of those things by 16, I get my 16 here, and 4 over 16 is 4 there. Now, this is the simplified version. When you're working, if you want to put parenthesis Y minus 0 parenthesis squared, when you're working, go right ahead. But we should know that this is a 0, right? Y minus 0. Okay. So that's the how. You got all that room to write whatever you need to write. Go. Which one's who? Colonel Mustard with the candlestick in the library. Gretchen, you're gone tomorrow, right?
Yeah.
Okay. You need one of these two then. Is there a track thing?
Yeah, it's Charlotte.
Who else is tracking? Okay. So I'm gonna need that because we're gonna go 7 into 6. Okay. That was sad.
I put it on the slice. You have to put that over so you can put the square angle. Yeah, for the X.
Where'd you get that?
Plus 4 Y squared. Y. 16. It's not 9, 16. 36. Well, that just happened. This is what's for the entire year. This is the first pencil I've kept through the whole year. First, I have to divide by 4. Yeah. Very
Eight or 9 cancel. 16.
Oh yeah. It's 9:60.
Only 3 is 12.
4 squared is 60.
1, 5, negative 60. 36, 36, 108, 48, 3, 16, 12.
Guess I got divided by the 4.
Check me before I wreck me. No mental math before lunch.
That's what we got.
I trust your numbers. I don't trust your words.
Yeah, you're wrong. I was gonna say
Jeez. Say it so vindictively. You're wrong. Okay, what do we think?
You're not even born in this. Yeah, but it doesn't make sense.
Yeah, so how was prom?
We didn't go to sophomores.
Actually, I did go.
Okay.
Prom's kind of overrated.
It's usually the main reason to go.
Yeah, the dance was so
I heard the DJ was kind of bad.
It was awful. Like, I think that the middle school dances were better. Yeah. They were. It was, there was 7 of us there, and at 9:30, there was 7 everyone. It was. We stayed till like 10:30, and the teachers were just like, "Good job, just staying." We were like, it was
So,
and the DJ tried to quit it by stopping the music 20 minutes. It was rough. Oh yeah, the music was.
Oh boy.
Yeah.
jeez.
That's
What was so bad about it?
Well, the DJ just like didn't care. And we'd be like, we'd try to request songs, and he'd be like, no, and he'd give us like these songs that nobody knew because they were from like the 80s.
You're from
And-
the
Why do those
And
songs?
some of them were like,
Dang.
but it
How
was
does that
like
feel,
boring
Sullivan?
songs.
I mean, I'm from the 80s. Like I was born in 84. I don't know those songs.
It just yeah. It was none of the.
All right. How'd we do? Are there any of them that we need to go through, like
C.
round C? 4x squared plus, factor out your 3, y squared plus 12y blank is negative 60. I said squared. Do as I say, not as I do. I'm a dad. I can get away with that. What do you add inside the parentheses? Did you really add 36? That's the thing that gets most kids. In two parts. Way number one, they'll forget to add 108 instead of 36. Way number two, they just don't write anything over there at all. Okay? You got to be careful with it. And then after that, turn that into y plus 6, divide, reduce. But we're cool with recognizing it, completing the square, even if I have to do it twice. Turns out it's not nearly as bad as we thought for the last 3 years. Okay. All right. Then you called it. If I take that focus, talking about eccentricity again, if I take that focus and I move it all the way out to the vertices, I've got a line. As soon as I pop it past those vertices, like, y'all remember that little silicone semicircle, like half sphere? And you'd invert it and you'd put it on the table and you just sit there and watch it and watch it and watch it, and it would pop and it would hit your friend at the next desk and your teacher would take it away. That's what these are. It's that ellipse popped outward as a pair of parabolas going outward instead. So it's going to have a lot of the same features. It's just like when we did the cosecant graph, you could see the sine graph in the middle of it. Very similar. It's going to have a lot of the same features or similar features, distant cousins. Okay? Where now I'm going to change up a bit of my vocabulary. Instead of a major axis, because it's not bound by the vertices, it doesn't stop at vertices, I call it a transverse axis. Transverse means to go across. Instead of actually putting points at co-vertices now, I just know that my conjugate axis is where my minor axis used to be. And now, you called it, those foci are going to be past the vertices. But do you see now the addition of asymptotes? The asymptotes are found with the A and B. I'm still going to A in this direction and A in that direction for my vertices. I'm going to pretend to B in this direction and B in that direction, because what I'm using those for is to create this kind of invisible box. I'll just make a mark here and a mark here, and then I will connect those two to see where my asymptotes go. Okay, so it's this little invisible box of up A over B or up B over A, depending which way I'm going, that tells me where my asymptotes are going to be. Oh, I think the next slide even has that. Yep. So the asymptotes themselves, you do need to graph those. But the box, you don't have to graph that. Okay? If you need the box to make your asymptotes, go for it. If you can just put little tick marks on there and you're good to go for it. Okay? But asymptotes, yes. Box, if you want. Notice that C is still to my foci. I'm still going to see out to my foci, but now my foci are past the vertices. How do you think that affects our C formula? Remember that it was a squared minus b squared before, which always put C smaller than A because I was subtracting. Now if I want my C and my foci to be past the vertices, I need it to be bigger than A, so that's what changes. C is now the square root of A squared plus B squared. That's what forces that focus out past the vertices. Boy, I live in Disney hell because now I'm seeing Mei Ling Li like trying to get through the portal and the panda being ripped off of her. Turning red. We've watched that so many times already. I live in Disney hell, okay? Just roll with it. Go to the equations. And yet again, I'm going to A this far, I'm going to B that far, C that far, except now I'm going to make asymptotes instead of connect for a potato. I want you to look at the equations and look at which way the hyperbola opens. Something's changing here from ellipses. The order switched on one of them. The order switched because of the real big idea. There's a subtraction now instead of add. Okay, that's important. Now look at where A squared is.
It's on the first one?
It's always on the first one, the positive one. That's the switch in how I determine A squared and B squared from an ellipse to a hyperbola. And an ellipse, A squared was the larger denominator. But in a hyperbola, A squared is just the positive denominator. Your A squared can be smaller than B squared. And after spending a couple of days on ellipses where A squared, you just pound it into your head, A squared is the big one. Now I'm going to say, only with ellipses. A squared can be smaller than B squared. A squared is just the positive denominator. Okay? That's the big change. And that's because I can have a hyperbola like this. I can also have a hyperbola like this. I can also have a hyperbola like this. Okay? The relationship between A and B determines my asymptotes, and the asymptotes determine whether it's big mamma jamma or skinny mini. Okay? So, let's see it. And just like with the ellipses, all that stuff, if you want to see it written out in coordinate form, is over here. Ooh, nope. One more thing. I want to say it before we get to the graph. If I A in that direction and I B in that direction, what is the slope of this line? B over A. This is B over A. Stop that. This one is written as y minus k is plus or minus b over a x minus h. But look in this one. I go up a, I go over b. The slope of this one is instead a over b. Y minus k is plus or minus a over b x minus h. Well, they're right down there. But what could I do to kind of keep that straight as to whether it's a over b or b over a? Because this is a ratio between a and b. What is the ratio on a line called? Slope. And slope, we have known since the dawn of time, is what over what? Rise over run. Is that y's over x's or x's over y's? If you want to remember that this is b over a, y's over x's, rise over run. If I want to remember this is a over b, y's over x's, a over b. Okay? Y's over x's, rise over run. All right, a lot of front loading. Here we go. Starting with A, nice and simple. They were so kind to us. Where is my center? 0, 0. And I'll label my coordinates off to the side on this one so it's easier to see the graph. Does this open vertically or horizontally? How do I know? Because the y squared term is positive, so it will open along the y-axis. And I know that A is 3 and B is 5. So I'm going to A, north and south, for my vertices. And I will write those. Vertex 1 is at 0, 3. Vertex 2 is at 0, negative 3. B was 5. Now I don't actually want to come out here and make a coordinate, a point at 5, because that's not a part of my graph. But I can come out here and say 1, 2, 3, 4, 5, just maybe like a little tick mark. 1, 2, 3, 4, 5, a little tick mark. Do you see where vertex and little tick mark will line up? Those are your asymptotes. My asymptotes are going to be, I'm going to rewrite this, y minus y1 is plus or minus slope x minus x1. I am going to get rid of that because I need to simplify it. Is this going to be a over b or b over a? Rise over run, y's over x's, a over b. Y's over x's, rise over run. So it's going to be plus or minus 3/5. Well, how could I simplify this? Yeah. So they're not always going to come out that nice, but this is plus or minus 3/5 x. So do you see where I don't actually need those tick marks? I don't need to connect all those tick marks with my box. If you need the box and the box helps you to make your asymptotes, go right ahead. But I don't need it because I know it's up 3, right 5. Up 3, right 5. Down 3, left 5. Down 3, left 5. There's my positive slope, my negative slope. Down 3, right 5. Down 3, right 5. Or up 3, back 5. Up 3, back 5. So do you see the box can help you, but the box is not necessary. Connect your dots. You got your asymptote. Your graph curls along the asymptotes, goes through the vertex, curls along the asymptotes. Curls along the asymptotes, goes through the vertex, curls along the asymptotes. I've got almost everything I need. I still need the foci. And foci are now c units apart, and c is now a squared plus b squared. So my foci are going to be at 0 plus or minus square root of 34. How far is that? Right? You look for a comparative perfect square. It's real close to 36. So it's going to be 5 and change. It's going to be almost 6. 1, 2, 3, 4, 5, almost 6. Focus. 1, 2, 3, 4, 5, almost 6. Focus. Okay? And I don't actually need these little tick marks there. That's my graph. All right, do it again, contestant 2. Where's my center at? -1, -2. Back 1, down 2, put a center. Whoop. Open vertically or horizontally? Horizontally this time, because the positive term is the direction of the open, is the direction of the transverse axis, is a squared. So that tells me my vertices, no, I do not want you to say -1 plus or minus 3. Actually write them out because those are values I can write. I'm going to go 3 to the right of that for a vertex. I'm going to go 3 to the left of that for a vertex. I will write what is 3 left and 3 right of this is at 2, -2, and at -4, -2. If I'm writing my asymptotes, don't ask a room full of teenagers, what is a simp? What is my slope? Someone immediately points to their friend. Okay, is it going to be A over B or B over A? B over A. Y's over X's, rise over run. So 4/3 X plus 1. You see where you can make that box. The box can be 3 this way, 4 this way, make box asymptotes through vertices, through corners. Or, if I just write the asymptote out ahead of time, can't I just from there go up 4, right 3? 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 3, 4, 1, 3. Connect dots. Ooh, that last one was bad. Go ahead and make your hyperbola. Curls along asymptotes. Hits vertex. Curls along asymptotes. Hits vertex. Almost there. Foci. Square root of a squared plus b squared. Well, 9 plus 16 is 25. Square root of 25 is 5, which is a value that I can actually write out. So I'm going to go 5 right and left of that center. Oh, 1, 2, 3, 4, 5. Focus. 1, 2, 3, 4, 5. Focus. So I'm going to go 5 right and left of my center. I'm going to be at 4, -2, and -6, -2. Now, if that was nasty instead, say that was square root of 24, I would simplify and rationalize. I'd call it 2 squared root of 3. And I'd have to write my foci as -1 plus or minus 2 root of 3, comma, -2. I'd have to switch it over to compound town. Okay? But do you get the kind of like an ellipse vibe out of this? It's not too different. I'm still A-ing and B-ing in different directions. So we're going to start nice. 1A, also a great segment on NPR. Start with 1A. Do not do 1B yet because I'm going to move the center on it. Yeah. Close enough. Well, remember that for every kid who gets 91.72 as their final grade, right? Specifically stated in the syllabus, by the way. I don't round. You want to earn it, earn it. And my foci. There we go. That's a square root, not negative. So center, HK, 0, 0. The positive term was the x term, so it's going to open horizontally. It also means the denominator of the x term is my a squared value. Square root of 4 is 2. Go 2 left and right for my vertices. Once I got my vertices, then asymptotes. You got to remember, a over b or b over a is more a question of y over x, rise over run. So in this case, square root of 1 over square root of 4 is 1/2. Because it goes through 0, 0, the y minus 0 and x minus 0 will reduce down. If you're going to sketch this instead of put it on an actual coordinate plane, that's perfectly legal. It's all good. Make sure it's proportional, though. So what I mean by proportional is you don't get to just do that every time and then write coordinates off to the side. When I say proportional, if that has a slope of plus or minus 1/2 for my asymptotes, then I expect to see a ratio of about 1 to 2 for your asymptotes. Okay? What if this was instead 2 over 1? This would not be your graph. Your graph would be much taller instead. Womp. Okay? So if you're going to sketch it, just sketch it proportionally. And I'm okay with you sketching it proportionally because, let's be honest, sometimes it's just annoying. All right. I'm just going to change a little bit. I just want a non-zero center. It was X first, right? No, it was Y. Yeah, there. Yeah. Yeah. There we go. Okay, I just want a non-zero center, so we're working with that. Be careful with your asymptotes here. They ain't going to be pretty. You can still ballpark them, but they are not pretty. Man, do we figure out all this radical business? My center, 4, -2, HK. My slope for my asymptotes. Well, first of all, which way is this opening? Okay. Vertically, because the y term is positive. So if it opens vertically, then I'm going to go north and south from here. A vertex at 4, -2 plus square root of 5. A vertex at 4, -2 minus square root of 5, which is 2.14 something, whatever. My foci are going to be, remember c is now the square root of a squared plus b squared. So simplify it. Almost 3 on your graph. So I'm going to go up to almost 3 foci. Focus is at 4, -2 plus 2 root of 2 is going to be at 4, -2 minus 2 root of 2. And for the asymptotes, we know it's y plus 2 is plus or minus slope x minus 4. The slope is a over b or b over a? Y is over x is a over b. But when a and b are radicals like square root of 5 and square root of 3, you're going to have to rationalize that. Square root of 15 over 3. Now I can still do that on my graph though, because square root of 15 is awful close to what? So from your point, 4, -2, can you go up almost 4 over 3? Almost 4 over 3. Just do that. That's perfectly fine. Okay, so we go up almost 4 over 3. Almost 4 over 3. And then connect the dots. Okay? What do we think so far? Maybe, ew. I can do it until you started doing that radical crap. I just don't like doing it? Okay, how about this? Can you do it? I don't care if you like it. Can you do it? What about the rest of the crew? Okay. It's kind of like that first time someone gives you tapioca pudding. Like, why are there all these like beads in it? Whatever, food. Okay. So this is more of the same, but now we're going to have to complete the square twice. I said, we're not quite there. And you actually beat out first hour by about 10 minutes. That's where they finished. So I'll cut it off there and I'll make sure your assignment is up to date before 5 p.m. Okay?